Welcome to lesson 1.3, absolute value. After this lesson and after our working class, you should be able to understand the absolute value of a rational number as its distance from zero on the number line, interpret absolute value for a positive or negative quantity in a real world situation, and decide comparisons of absolute value from statements of order. Today you're going to need 5 colored pencils. Red, blue, green, orange, and purple are what I'm going to use. Again, as long as you stay consistent, you're all right. All right, so first off, we are going to practice with absolute value. So absolute value just tells us how far away a number is from zero. It doesn't tell us which direction. It just says it is this many spaces. So in this case, we're going to look at the absolute value for -7. So if I go on here, so I'm actually going to use my red. So if I go on here and I find -7 and I count to 0, so 1, 2, 3, 4, 5, 6, 7. That tells me that -7 is 7 spaces from 0. That's all we want to know. We don't care which direction, we just want to know how many spaces. We don't care up, down, left, right, just how many. All right, so then let's try number 5. Or try the absolute value of 5, letter B, I should say. So again, plot 5 and then count back to 0. 1, 2, 3, 4, whoops, and 5. Ran off the page. So the absolute value of 5 is 5 because it's 5 spaces away from 0. Okay, and then I'm just going to use my regular colored pencil for 7. So now I'm doing +7. +7 is 1, 2, 3, 4, 5, 6, 7. So +7 is also 7 spaces from 0. Well, let's take a look at this. I have -7 and 7 that have the same absolute value. -7 and 7 we also know are opposites. And according to the definition, opposites have to be the same distance from 0, but in opposite directions. So in this case, opposites does deal with direction, absolute value does not. So it would make sense that 7 and -7 would have the same absolute value, since in order to be opposites, they have to be the same distance from 0. In this case, that distance is 7. All right, now we're going to try -2. So I'm going to plot -2, and I'm actually going to draw under my number line here. So 1, 2. So -2 is 2 spaces from 0. And then 4, I'm going to use yellow here. We know is 1, 2, 3, 4 spaces from 0. And then green. -4, so -4 and 4 are opposites, so they should be the same distance from 0. So in this case, the absolute value of -4 should be 4. 1, 2, 3, 4. And it was. Okay, so absolute value is actually pretty simple. The most common mistake students make is that when it's the absolute value of a positive number, we like to give it a negative sign in the answer. That's opposites. Absolute value is not going to have a negative number. Okay, it's really not even necessarily positive. It's just saying it is this many spaces away. When we talk about distance, distance really doesn't have a negative or a positive. It's just how far is it? All right, so here we go. Which pairs of numbers have the same absolute value, and how are these numbers related? Well, we just talked about that, and we said that -7 and 7 have the same absolute value, and 4 and -4 have the same absolute value. And then the next question was, how are these numbers related? These numbers are both opposites of one another. Okay, and we talked about that previously when we looked at their absolute values. So, sorry about that. So, negative numbers are less than positive numbers. Does this mean the absolute value of a negative number must be less than the absolute value of a positive number? So since negative numbers are always smaller than positive numbers, we have to think about the absolute value and the absolute value of a negative number. Now remember, absolute value is just how many spaces it is from 0. So in this case, a negative absolute value is not going to be less than a positive absolute value. And the reason being is because it's a non-negative number. So when you find the absolute value, it just gives you the distance. So the absolute value of a positive number and the absolute value of a negative number are going to have the same value. Okay, so no negative number's absolute value is not smaller than a positive number's absolute value because absolute values are non-negative. Okay? Absolute values only tell you a number's distance from 0, not the direction, making it not positive nor negative. Okay, now in theory the number is positive because it doesn't have the negative sign, blah, 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 but we're going to get into the idea of these numbers not being either because distance is just that. If I say somebody is 3 feet away from me, I don't say negative 3 feet because they're behind me, it's just they're 3 feet away. Okay, so that one is a little bit harder. We'll continue to work on that, and I promise you we'll continue to work on it in 7th grade too. Okay, absolute value in a real world situation. So we have Jake who uses his online music store gift card to buy an album of songs by his favorite band. We're going to find the negative number that represents the change in the balance on Jake's card after his purchase. All right, so first we're going to find the negative integer that represents the change in his balance. So his account balance is $25, and in his cart is a $10 album. So in this case, it would be a negative $10 because he's going to pay $10. So what that means to us is that the balance on Jake's gift card went down $10. So the change would be a negative number. I think I put too many spaces there. There we go. Okay, so the balance on the gift card went down $10. So if we were to give an integer for the change, that change would be negative 10. Okay, now the next thing we're going to do is we're going to explain how the absolute value would be used to express that number in this situation. So in this case, we're going to use the number line and we find that negative 10 is 10 units from 0. So the absolute value of negative 10 is $10. Okay, and so the reason that we're doing this is so that way we can put what's happening into words. So as a number, it's a negative 10. So the negative 10 implies that it's coming out of his account. However, if I'm going to put it into words, I can't say that it went down negative $10. Okay, it's like a double negative in English. Okay, that means the opposite of what you're actually thinking. So if we're going to put it into words, we actually have to find the absolute value of the number, which is 10. And then we use the word, so like here we use the word decreased to show that it went down $10. Okay, so the absolute value allows us to put the situation into words and to do so correctly. So again, if I would have said it decreased negative $10, I would have been incorrect. But since I found the absolute value, I was able to say that the balance on Jake's card decreased by $10. You have to use that absolute value if you're using the descriptive word. Explain why the absolute value of a negative number will never be negative. All right, so I want you to take a second and try to answer this one on your own, and when you come back, we'll check your answer. Okay, so the absolute value of a number always tells a number's distance from 0. Since it is distance, the number is always a non-negative because distance does not include direction when it comes to the number. Okay, so absolute value tells the number's distance from 0, and since it's telling you the distance, we're not including the direction. Absolute value just tells you how far, not which way. All right, so I think at this point you're able to try these your turns on your own, and then when you come back, we'll check your answers. All right, so in this case, we should have noticed, we should have squared that negative 13 was an important number. We should have highlighted that we need to write an equivalent statement about the temperature using absolute value of the number. So write an equivalent statement would be what we circle. Okay, so it reached a negative 13 degrees. Well, we're going to use the absolute value of negative 13, which is 13, and then we're going to use what that negative means and put it in words. Negative in this case means, so negatives for temperature mean below 0. So in this case, the temperature reached 13 degrees Fahrenheit below 0. Okay, if I would have done negative 13 below 0, it would have been incorrect. Here we would have gotten 12, 0, 91, 88, 55, and 1. All right, so we're going to keep going here onto our Explore activity, and this will actually be one of the last things that we do today. So here we go. We have Maria, Susan, George, and Antonio who check their credit card balances on their smartphones, and the amounts are as shown. So we're going to answer the following questions, and when we're done, we're going to have enough clues to match the smartphone with the correct person. Okay, so I want you, if you're ready to try this on your own, and then come back and check your work. Otherwise, stick with me. So Maria's credit card balance is less than negative $30. Does Maria owe more than 30 or less than 30? So since the credit card balance is less than negative 30, think about your number line. Less than negative 30 means that it's closer to 0. So she actually owes, less than negative 30 means it's further from 0 because it's furthest to the left. My bad. And so that actually means she owes more than $30. Because if I were to compare these, the amount Maria owes has to be less than negative 30. So a number less than negative 30 would be like negative 31, negative 32. Those numbers mean she owes more money. Susan's credit card balance is greater than negative 25. So Susan's is greater than negative 25. So what that means is that she actually owes less than $25. George's credit card balance is $5 less than Susan's balance. Does George owe more than Susan or less than Susan? So George's is $5 less than. So since it's less than, he's actually going to owe more. So it's the account that's less, which means he actually owes more. Antonio owes $15 less than Maria owes. This means that Antonio's balance, so what he owes is less, which means the value of his account is actually greater than Maria's. So let's take a look at this. Maria owes more than $30. So here, let's take a look. Who owes more than $30? Well, here it says you owe. It doesn't have negatives, so we have to use the absolute value. In this case, she owes 45. This person owes 45, and that's the only one that's a larger amount in terms of owing than 30. So even though this value is less than 30, she owes more than the $30. All right, so now Susan's credit card balance is greater than negative 25. So it's greater than negative 25. Well, in this case, owing 30 is less than negative 25. So she owes more, so the value is less. So the only option here is for Susan to owe $20. We know that George owes $5 more than Susan owes. So if Susan owes 20, George has to owe 25. And we know that Antonia owes $15 less than Maria. So if Maria owes 45, owing $15 less than that would be 30. So Antonio owes $30. Again, I know it's tough. We'll continue to work through these things. Okay, so use absolute value to describe the relationship between a negative credit card balance and the amount owed. All right, so in this case, a negative balance, so the the absolute value of the negative number would equal the amount that is owed. So let's say that in my account I had a negative $32. Well, then the absolute value of that negative 32, I don't know why those aren't showing up as lines. I will draw them. So that absolute value of negative 32 is going to tell me how much I owe so I can put it into words. So that equals 32. So because of that, I owe $32. All right, so the next part here is your guided practice. All right, I want you to try these problems and make sure to do your self-assessment. As always, if you have any questions, please be sure to write them down or email me so we can go over them in class.